Alright, so what we're going to do in this lecture, we're going to use a look at another method that you can use to analyze heat exchanger performance, and that is referred to as being the effectiveness, or epsilon NTU number of transfer units method. And if you recall, at the end of the last lecture, we looked at a problem using LMTD, where if you do not know one of your exit temperatures, and you have no way of solving it, it requires an iteration in order to apply LMTD, which can be a little bit on the tedious side. And so that's why we're going to look at this new method, Effectiveness-NTU. Okay, so if we're posed with a problem where we just know the inlet temperatures and the mass flow rates of our two fluid streams, we cannot determine the exit temperatures, and consequently, when applying LMTD or the LMTD method, you cannot evaluate that, and the solution requires a bit of a tedious iteration, as we saw at the end of the last lecture when we were working an example problem that fit this description. So in these cases, we use the Effectiveness-NTU method. So what is the Effectiveness-NTU? Well, let's begin by defining effectiveness. Effectiveness is defined as being the amount of heat exchange or heat transfer that goes on within our heat exchanger divided by the maximum possible heat exchange that could take place between the two fluid streams. So, with that, you may ask, how do we determine what the maximum possible heat transfer is? And in order to do that, we have to look at a certain attribute of both of the fluid streams. That's what we'll talk about now. Okay. So what we find is the maximum possible heat transfer can be determined by taking the minimum m dot c sub p, and we'll have C min is what we'll be calling that in this technique. But the minimum fluid would have to undergo the maximum possible temperature difference, and the maximum possible temperature difference will be the difference in temperature between the hot fluid in and the cold fluid in. And so that is the way that we get Q max. So let's take a look at a temperature diagram in terms of what we're referring to here. So imagine we have a scenario where we have our cold fluid. This is a counterflow heat exchanger. T hot in is here. T cold 1 would be there. T cold 2 is there, T hot 2 is there. Now, if we're looking at the maximum possible temperature difference between these two fluid streams, it is going to be this difference here. And so that is the maximum possible temperature difference that exists. And so with that, what we can write is Q max m dot c sub p for our minimum fluid, that would be the fluid where m dot c sub p is the smallest, multiplied by the difference of hot in minus cold in. That would be the maximum temperature swing that we could get. And so with that, if you know your effectiveness, and if you know this value of Q max, you can determine the heat exchange that is occurring within your heat exchanger. And so we calculate Q in the following manner then. Okay, so that is the way that we evaluate the heat transfer if you know your effectiveness and you know your minimum fluid. Other terms to use, or the terms that are common in the Effectiveness-NTU method. We've already talked about the minimum fluid, but we define that as being C min and C max. And we'll also look at the ratio of these two, but we won't do it here. We'll do that later on. Other things we have, NTU, those are number of transfer units. And NTU is defined as being our overall heat transfer coefficient multiplied by the area divided by C min for the minimum fluid. And this is going to come from figures or equations. Just like with LMTD, we looked up the F factor, you'll look up an NTU factor, and NTU and effectiveness are plotted together. And from figures, or there are also equations that you can use. The equations are more accurate, but they take a little bit longer, but that's probably the better way to go. And then the effectiveness. And so here you use figures or equations again. And then effectiveness is also so another way that you can express it is just in terms of the delta T of the two fluid streams. So you take the delta T of the minimum fluid divided by the maximum temperature difference in the heat exchanger. So those are some of the terms that we'll use in the Effectiveness-NTU. What we're going to do in the next segment, we're going to look at two different types of problems that you can solve, and then we'll apply it later on in this lecture, solving an example problem that involves the Effectiveness-NTU method.